everybody. So everybody say hi to Murphy. Murphy. Turn your head around. Murphy. Good boy. And then Ava. Good morning, Ava. All right. So I had a request for two problems. One is an actual problem out of the book, and one is to try and explain how to deal with some complex numbers. So first of all, number 22 out of section 4.3. Don't mean to zoom around on you a little bit, but basically it's this one. The U.S. Census tracks the percentage of persons 23 years or older who are college graduates, and then you have your data set here. So one of the things that you can do to make your life a little bit better, and I know I'm going to upset anybody in the future with a textbook that borrows this, but make this a 0 when you type it in, make this a 2, make this a 4. You're just transforming your data, and you just have to remember that you're transforming it this way. So then there's a 6, an 8, a 10, a 12, a 14, a 16, and an 18. You're basically making your base year the 0. Okay, so 1990 is your starting year. And what you'll do is on your calculator, you'll go to Stat, you'll hit Edit, and in L1, put in the 0 through the 18. And again, it's going by 2s each time. And then in L2, you'll put your 21.3, your 21.4, your 22.2, so on down. After you've done that, you'll hit your Stat key, you'll hit your Calculate, and you'll do your lin reg AX plus B. And the A that you should get is approximately 0.476, and the B that you get is about 20.745. And I'm going to take that and plug that into my y equals, that's referred to as your prediction equation. If you're taking a bunch of stats classes, then they put a hat above that, but I don't need you to do that. So your prediction equation should give you an idea when or what something will be off into the future. A little bit. We need to be careful with that, although because algebra will use the models to predict things in the future, and statistically that's actually in violation of procedure. So just be careful with that. If you go out 4 or 5 years, not a big deal, but if you're going out 20 years, it's a big issue. So I put down to start with 0.35, and I went, wait a second, that's a problem, because they gave us the data with the decimal already adjusted. So we need to treat our 35% as 35, not 0.35. So we use 35 is equal to 0.476x plus 20.745. We're trying to figure out in what year is this the percentage. So we're solving this problem for x. All right, so just do the algebra manipulation to be able to get that. Hopefully that makes sense. Let's talk about the complex problem. Suppose you have a degree of 2, and you're told that 2 plus 3i is a root. And it says, find a possible equation. Now the thing is we're not trying to find the specific equation because we're not given a point. So there's actually multiple equations that will generate 2 plus 3i, and then its counterpart, 2 minus 3i as a root. We know that these always come in pairs, and it's the conjugate that is its other root. So if you have 2 plus 3i as a root, 2 minus 3i as a root. Now I made a typo here, and I'll bring that up in a second, but if 2 plus 3i is a root, then x minus 2 plus 3i equals 0, so this will be the factor. And if 2 minus 3i is a root, then x minus 2 minus 3i is a factor. So we're going to take our two factors, and we're going to multiply them together. And in my head, I went, oh, I need a plus here. And I was thinking conjugate, and no, the plus occurs here, and then there's the minus there. And after you distribute your negatives, you'll get x minus 2 plus 3i and x minus 2 minus 3i. So just be cautious with that. And then you multiply these out. So I've got x squared minus 2x plus 3xi. Then I'm going to take the 2 through, and I get negative 2x plus 4 minus 6i. When I started taking the negative 3i through, I noticed that I got opposites of things. So I had negative 3ix. So I just put that underneath there, and since one was positive and one was negative, they eliminate each other. And then I took negative 3i and then negative 2, and I got a positive 6i. I'm sorry, I lied. Yeah, that's right. Nope, I'm correct on that. I thought I did 2 for a moment, forgive me. So negative 3i and the negative 2 is positive 6i, and those eliminate. And then the negative 3i and the positive 3i is a negative 9i squared. And recall that I squared is a negative 1, so this actually becomes positive 9. And so your function, a function that has these as roots, is x squared minus 4x plus 13. Now, it could also be that you could multiply by 2. You could say it's 2x squared minus minus 8x plus 26. That would also have those roots. So, unless they give you a specific point which it must travel through, this is satisfactory. Okay, hopefully that helps.